Let's try again. Okay, so I come from New York. I work at a company called Blue Apron. I help them turn millions of pounds of raw goods into prepped ingredients that we ship across the country for families to cook delicious meals together. A little bit about me and what I've been working on recently. Over the summer, I worked on a microservice in Ruby, which printed out shipping labels and stuck them to our Blue Apron boxes. I also just got a cat, so like most cat owners, I spend a lot of my free time taking pictures of him while he sleeps. Okay, so let's get started. How many people in here are programmers? Awesome. How many people write primarily in Ruby? Great. And how many people in here can say with confidence that their Ruby code is running as fast as possible? One? There was one at the last talk, too. There's always the one. Okay, so that's okay. As programmers, we have a lot going on. We are writing code and writing tests. We're deploying code. We have meetings. We have communication with product managers, engineering managers. We're fixing our own bugs. We're fixing other people's bugs. Let me use the microphone. I think this is... Can you hear me? Okay. So as programmers, we have a lot going on. And it's not necessarily our responsibility or our priorities to make sure our code is running fast as long as it's running efficiently. Ruby is a great example of an open source language that we depend on among other different projects that we rely on to make sure that our projects are actually doing what is expected. Okay, so I'm just going to give a little bit of an outline of what I'm going to be going over. First, we're going to talk about what happens when you execute your Ruby code at runtime. Then we're going to talk about how to speed up your Ruby code. And then we're going to dive into some of the Ruby source code. So first, let's talk about what happens at runtime. So can anyone tell me from this block of code what this method is? Say it again. Okay, he said pop. He's right. It's much shorter, much easier, and that's why we love coding in Ruby. So how do Ruby methods work? First, we have our code that we write out, nice and pretty. And then that is, okay, so here's an example of a really simple Ruby script. Say hello, we have our definition of the method, an argument, the execution of the code, and then we're invoking the code down here with its argument. So first, this is turned into tokens. And bear with me, because I'm going to have to go back and forth between typing. But first, this is turned into tokens. So we can actually use the Ruby method, our Ruby library Ripper, to go over a script and display what is happening when we are compiling Ruby code and interpreting it. So first, we have the script that we were using as an example. So as you can see, the tokenize has turned each piece of the script into more digestible chunks. Say hello. So the next step is to parse that into an abstract syntax tree. So we can also use the Ripper library to represent what a script would look like in that format as well. Okay, so what we've done is we've actually converted that script into a symbolic expression. Yes, a symbolic expression tree. And so what we have here is a tree structure. We're defining it as a program. We have our definition, the name of the method, the parameters, the name. We've indicated down here that it's a void statement because we're not returning anything because we're using a puts. We have put statement, string literal with the string content, hello, and then a string embedded expression name and more string content, and then the invocation of the method down here, say hello with string content RubyDay. So after that, that's converted into bytecode. and then it's interpreted by the YARV, which is the Ruby Virtual Machine. And YARV stands for, as we all know, yet another Ruby VM. So what we can actually do is look at what happens when that code is compiled. So here we have this structure that we have of a compiled object. And so now we can actually disassemble this compiled object so that we can see what the Ruby VM is actually looking at. So as you can see here, we have instructions for the VM to execute the code. Can anyone tell me what language this looks like? Yes, assembly. Okay. And just to keep in mind, this is only for Ruby that's interpreted by the C library. There's also JRuby, which is run in the Java VM, and then there's also Rubiness, which is executed another way. And so next we're going to talk about speeding up our Ruby code. Okay, so enough of typing for a little bit. So I'm going to talk about how this topic actually came to fruition and how we actually started looking at Ruby code and trying to see how we can make it faster. So I was speaking with some of my coworkers, and we were thinking about how we wanted to test incoming candidates for when we were interviewing them. So we wanted to do something that was relevant because across the company we have different departments and we're all using different uses of Ruby. And so we're using Rails and we're using plain Ruby and different frameworks. And so one of my coworkers actually asks candidates to rewrite flatten. And so you have, he wants them to write it recursively and then without recursion. And so you have the knowledge of Ruby, and then we can also kind of test the computer science fundamentals and see if they actually understand how that works. So what happened is we started whiteboarding to make sure that we could actually figure out how to write that problem ourselves. And so I came up with a solution that I was happy with the help of my coworkers. We ran some tests on it to make sure that it was a correct solution, and then we benchmarked it. And so what happened was, with the input that we had provided, the version that I had come up with was actually faster than the Ruby version, which was a big surprise to me and everyone else. So I went home and started thinking, okay, well, this is really weird because why wouldn't the Ruby code just be the faster than the implementation that I had built? I'd never really thought about it because as a developer, especially as a Rubyist, you are thinking about other things, not necessarily performance. You're thinking about, okay, is this readable? Is this scalable? All of these other things, and performance isn't really top of the list. So okay, so next, what is Ruby racing? So I went home and started implementing different methods in Ruby to see if I could actually beat the Ruby versions with the Ruby versions I had created against the Ruby versions that are provided to me by the Ruby library. So instead of just writing benchmarking again and again, I actually created a Ruby gem that you are able to pass in your own implementation of a Ruby method and then race it to see which one is faster. So I actually uploaded it to Ruby Gems. It's called Ruby Racer. If anyone wants to try it out, you're able to gem install Ruby Racer. It only works with arrays and enumerables, sorry. So if you can help me make it better and do other, be compatible with other object types, feel free to make a pull request. And so how it works is you require the gem, you require the method that you've written, you define your own input, you pass your customized method into a proc, and then you run the method. So now we're going to do a demo. Okay, so first, as I explained before, I tested with flatten. So I'm going to show you how how should I do this? Yeah, that would be really helpful. Okay, so first I'm going to show you guys what the implementation was, and then we're going to raise the methods. So we have show method flatten. And so as you can see here, we are duplicating the input. We're iterating over it using kind of a stack structure. Yeah, a stack structure. And then we are returning a new array. And so we have defined our flatten input. We have our flatten proc. And now we can race it. Okay. So that time it was slower. We run it again. I lose again. Okay. So with this input, it actually shows that the input that I have provided actually makes the method go slower. But then when I was actually doing it at work, the input that we had provided was actually making the method go faster. So the next one that I'm going to show is unique. Right? No, sort. Okay, so let's go over sort. So, oops. Oh, show method. Okay, and so this is actually an implementation of the quicksort algorithm, which is what Ruby uses for their own library. So there's not a lot to see here. It's just simple quicksort. And so once again, we have a sort input, which is, yeah, so we have a reversed array. And then so we are able to do the, let's see. It's obviously going to be slower. It has the runtime complexity of the sort algorithm is obviously O log n, so it does have, when we're running it in Ruby, it's 2 times slower than the implementation that we've written in C because of that average higher complexity. Okay, so the next one that we're going to do is unique. So this is an implementation of unique that I created. We are using a while loop instead of an each. I'll go into that later as to why I did that. And then, as you can see here, there's an implementation of includes, so that I instead, to keep it at a rewritten level, and so that I wasn't using a lot of the Ruby methods that are provided for me, I also rewrote contain. And so this is also a linear method. It passes in the array and iterates over it until we have an answer, a return value. So now we have an input for unique. And then let's erase the code. Okay, so this one, it comes really close. As you can see, one time it lost and one time it won. So this one, is really, it comes really close to it. And so the more times that you run it, because of the environment that you're in, you're going to have a different runtime. Yeah, you're going to have a different runtime each time. If this was in an isolated environment, it would probably be a better, more consistent solution. And so the last method that I'm going to show, there's 2 of them actually. So we're going to show max. And so here we have another linear implementation of max. And so it goes to the array, it assigns it when we find a max, and then it returns the max value. So we will do max input. And so we do okay, so this one you could see is much faster. And we have also so I can show you. I also have an implementation of min, which follows the same pattern, but I can just show you. So we have min, and so as you can see, it's the same pattern, linear, it assigns it when it finds it, and then it returns the minimum value. And so, Ruby eraser, go, min input. Oh, and minimum input also equals maximum input, just to keep it consistent. And so as you can see, same results, minimum and maximum actually, because of their runtime complexity, they are more consistently faster in Ruby. Okay, so what makes Ruby code, thank you, what makes Ruby code faster? So primitive operations are fast. As I explained before, I had originally started writing these methods using each. I found that there wasn't enough of it wasn't as fast as I wanted it to be, so I decided to use even lower level iterative methods. So while loops are a really good example of that, where we're in a loop until the conditional is met, and then we execute the loop. So here you can see it does the same thing, but we're just using a while loop. And then here's an example of the benchmarking. So I ran this specific operation 1 million times. The input is just a 3-element array. And we can see here that the while loop is actually about 12% faster than the using each. And when I actually broke it down more, it was that the invocation of the block was actually slowing down the implementation of the code. Okay, so array mutation is expensive. This is something else that I found while I was rewriting methods. So as we can see here, we have the same output. We could possibly have the same input, but we have two completely different implementations of the exact same thing. So not both of them are going to be appropriate for every scenario. As in Ruby, we don't always know the length of our array, but in some cases we do. And so as you could see, appending to an array is the same as using an assignment to an index. So here we have a benchmark of what appending versus assignment in an array. And when it's run, assignment was actually 10% slower than using append on an element. But like I said before, we don't always know the length of an array, so sometimes appending is the method that we need. And then complex algorithms are slow. So as you saw in my demo, when you have algorithms with a more complex runtime, when they're doing more, they actually become slower in Ruby, and so when we actually want to use the library versions that are provided for us. But when we have more methods with less complexity, we can actually rewrite them in Ruby, and they will be faster most of the time. And so now I'd like to dive into some source code. Good. Okay, so first I'm going to go into the Ruby method flatten, as I talked about before. So just to give you an indication of what's happening here, instead of me flicking through the source code, I have some compacted methods straight from the Ruby library. I've indicated the file name on top and the line number that I'm talking about. So first we have array method flatten. And so what we have here is we're actually creating a result from a private method flatten, which is provided in the array file for the Ruby library. And so now we come into flatten, and this flatten is actually the same flatten that flatten bang uses. So they use the same algorithm except without manipulating the original input. So as you can see here, similar to the solution that I had originally created, it does use a stack to manipulate the array and to flatten it out. And then we also are creating a new array from that result. And so when we move down the flatten, we see a while loop, and then within the while loop, we have a few conditionals. And so one thing to note here is we have this array push, and so as we're iterating through the array, we're pushing into the stack that we've created. And then the next point here is that we have a guard at the top of the while loop, and so when this conditional is made, we're pushing into the result array. So next, I'm going to talk a little bit about unique. Let's see. So we're at Ruby unique, yes. And so at the top here, before we've even done anything, we actually have this conditional here, and it says that if the array length is less than or equal to 1, we're just duplicating the array and returning it, which is probably what we would be doing if we were writing our Ruby code anyways, creating a guard that catches any condition that we wouldn't want to enter the method and just return a standard solution. No, whatever, return value. And so the next step here is that we are creating a hash from this array. So the implementation that I had done was using iterations over the array that was created. Ruby's method actually uses a hash lookup, and it takes the values from the hash lookup and it returns the unique array. So the next part here is sort. As you can see, Ruby sort is actually much shorter than I expected it to be. All we're doing is duplicating the array and then taking the Ruby sort public method and using that and returning an array. Okay, so just to go back, there are a few factors that will affect performance, but if we are willing to sacrifice other methodologies. So for example, using the while loop, that's a good way to make your Ruby code a lot faster, but at what expense? While loops don't necessarily read as well as other Ruby codes, as other blocks. They're not necessarily the most the easiest to break. So if we're meta-conditional, we end the while loop. If we have an each loop, we already have a definitive end, and we don't have to break the loop. And so how do we define code quality? I think this is interesting because performance is one factor of code quality, but it's definitely not the entire, it's not the entire basis of it. Code quality, it comes from a number of things. Are we able to test the code? Does the code have tests in general? Is it scalable? Is it readable? There's a lot of things that affect code quality. And we should not, we shouldn't define code quality just by performance, which I said that. And so what is Ruby best at? As we saw that Ruby might not be the fastest language, but it's good at other things. We have good documentation, we have a great community. It's easy we saw a talk earlier, it's easy for junior developers to learn. There's a lot of things that Ruby is good at that other languages aren't good at. It also has a cool logo. Okay, and then this is a great quote that kind of encompasses what Ruby is good at. I didn't work hard to make Ruby perfect for everyone because you feel differently from me. No language is perfect for everyone. The perfect language for Guido van Rossum is probably Python from Mats. For those of you that don't know, Guido van Rossum wrote Python. Okay, So some resources that I used while I was actually investigating this talk. I don't know how many of you have a Python background, but there is a library, Python, that's written in Python. It's the Python language written in Python that's faster than the original Python, if that makes sense. So that is due to their JIT interpreter, which is the just-in-time interpreter. When you run Python code, it compiles it and runs it at execution time. And there's actually a quote on the website. If you remember that guy I just talked about, Guido van Rossum, if you want your code to be run faster, you should probably just use PyPy. And this is another great book, a big inspiration for this talk, Ruby Under the Microscope by Pat Shaughnessy. I think I said that right. And so what this is, it goes through a lot of the Ruby internals, how it's compiled, what happens under the hood, how classes are defined, different object types and whatnot. He also has a really great blog that has condensed versions of what is available in his book. So I'm sure some people are wondering why you would ever bother doing this, because why wouldn't I just use the library that we're given? I think as developers, we should always be questioning what we think we know. That's what I did when I started working on this talk. I took something that I thought was truth, and it ended up not being truth. So I think this is a really good lesson for me, because we should always be testing what we know, and experimenting is fun, and so is experimenting with code. And with that, I will leave you with Ruby is designed to make programmers happy. Thank you. Yeah, he asked if I've thought about doing it. To be honest, not really. I should. I encourage everyone else to, but no, I haven't really. I think for the products that I'm working on, performance isn't as much of a priority as with not all Ruby applications, but some of them. Performance isn't quite the thing. There are things. We have a lot of junior developers. Do we want it to be? We have a lot of people who are very really strong Rubyists. If they saw me writing my while loops, they would be like, "Don't do that." So, thanks. Okay, is that it? All right. Thank you.